What if we could launch satellites into space without using giant rockets or burning tons of explosive fuel? It might sound like science fiction, but a company called SpinLaunch is making it real. Using a massive centrifuge, they can hurl satellites at speeds of 5,000 miles per hour before sending them into orbit. This breakthrough could cut costs, reduce pollution, and make space accessible to more people than ever before. Let's explore how this incredible technology works and why it could change space travel forever. The problem with traditional rocket launches. Rocket launches are amazing feats of engineering, but they're also extremely expensive and resource-heavy. A typical launch can cost millions of dollars, with a price tag of around $6,000 per kilogram to send something into orbit. Most of this cost comes from building and fueling massive rockets, which are often used only once. On top of that, the fuel they burn releases harmful emissions into the atmosphere. Preparing for a launch can take months or even years, slowing down space projects. These limitations mean that only a few governments and wealthy companies can afford to send satellites into space. For smaller organizations, students, or developing nations, reaching orbit remains a distant dream, until now. The vision behind SpinLaunch. SpinLaunch was created to break down these barriers to space. The idea was simple yet revolutionary: launch satellites without relying on massive rockets or huge amounts of explosive fuel. Instead, use kinetic energy, the energy of motion, to propel satellites into the sky. This concept could lower costs, reduce environmental harm, and make launches more frequent. The company's founder, Jonathan Yaney, wanted to rethink how we reach space entirely. Rather than building bigger rockets, he envisioned using the laws of physics to give satellites a head start before they even fired their own engines. This vision is not just about technology. It's about opening space access to schools, startups, and countries that have never launched anything before. How the kinetic launch system works. At the heart of SpinLaunch's design is a giant centrifuge, a machine that spins objects in a circle at extreme speeds. Inside a massive vacuum chamber, a rotating arm accelerates a payload until it reaches about 5,000 miles per hour. Then, at the precise moment, the payload is released through a launch tube and into the upper atmosphere. From there, a small rocket engine provides the final push into orbit. By handling the hardest part of the journey, escaping Earth's lower atmosphere, without fuel-hungry rockets, SpinLaunch drastically reduces launch costs. The process is efficient, repeatable, and could allow multiple launches in a single day, something traditional space companies can only dream about. The suborbital accelerator at Spaceport America. To test their concept, SpinLaunch built the suborbital accelerator at Spaceport America in New Mexico. This giant structure stands 33 meters tall and contains the world's largest vacuum-sealed centrifuge. The vacuum chamber removes air resistance, allowing the rotating arm to spin faster without overheating or slowing down. The suborbital accelerator is designed for testing and can launch smaller payloads on suborbital flights, meaning they reach high altitudes but don't complete a full orbit. These tests are crucial for perfecting the timing, mechanics, and aerodynamics of the system before building a larger, orbital version. Located in a wide, open desert, the facility has the space and safety features needed for repeated high-speed launches. Record-breaking test launches. Since its construction, the suborbital accelerator has achieved several impressive test flights. In each test, engineers placed small payloads inside the centrifuge, spun them to incredible speeds, and released them toward the sky. Some of these test launches have reached velocities of 5,000 miles per hour, proof that the concept works outside of theory. The data collected from these flights helps improve everything from payload design to launch timing. These successes have also drawn attention from NASA, the U.S. Department of Defense, and commercial satellite companies interested in cheaper, faster launch options. While these tests aren't yet putting satellites into orbit, they show that the technology is advancing rapidly toward that goal. Cutting launch costs in half. One of SpinLaunch's biggest promises is affordability. By reducing the need for expensive rocket fuel and reusing the launch system, they believe they can cut costs from about $6,000 per kilogram to under $1,500. This could completely change the space industry's economics. Schools could send their own satellites for science experiments. Startups could launch communication devices or Earth monitoring tools without massive investments. Even developing nations could access space for disaster monitoring or agricultural planning. Lower costs mean more frequent launches, which can speed up technological progress. Instead of waiting years for a launch slot, small organizations could get their payloads into orbit within weeks, making space far more accessible than it has ever been. Environmental benefits of kinetic launches. Traditional rocket launches burn large quantities of fossil fuels, releasing carbon dioxide and other pollutants into the atmosphere. Some even use fuels that damage the ozone layer. Spin Launch's system avoids most of this because it uses electric motors to spin the centrifuge. These motors can run on renewable energy sources like solar or wind power, making the process far cleaner. Less fuel also means less risk of accidental explosions during launch preparation. In an era when climate change is a major concern, a technology that can open access to space without harming the planet has a huge advantage. If widely adopted, kinetic launch systems could help the space industry become more environmentally responsible. Challenges and limitations. Despite its promise, Spin Launch's technology faces real challenges. The acceleration forces inside the centrifuge are enormous, much higher than what most satellites are designed to handle. This means payloads must be built to withstand intense stress, which could limit the types of missions possible. Another limitation is that the system can't take a payload directly into orbit. A small rocket stage is still needed for the final boost, so the method doesn't eliminate rockets entirely. Weather conditions, such as high winds, could also affect launch schedules. Overcoming these hurdles will require more engineering breakthroughs, partnerships with satellite designers, and further testing before the technology can be widely used for orbital missions. Future plans and orbital launch goals. Spin Launch isn't stopping with suborbital tests. Their goal is to build a much larger centrifuge capable of launching payloads directly toward low Earth orbit. This full-scale system would handle heavier satellites, possibly up to several hundred kilograms each, and launch them multiple times per week. The company is also working with partners to design satellites that can survive the intense forces of kinetic launch. If successful, this could lead to a network of spin launch facilities around the world, enabling global access to affordable space launches. The ultimate aim is to make sending something into space as routine as flying a cargo plane across the ocean. What this could mean for the future of space. If Spin Launch reaches its full potential, space access could shift from being rare and costly to something routine and affordable. With lower prices and faster turnaround, more satellites could be launched for purposes like global internet, disaster monitoring, and advanced scientific research. Space exploration might become less dependent on massive government budgets, opening doors for startups, universities, and smaller nations. This could also accelerate projects like lunar bases, asteroid mining, and deep space missions. By removing barriers, Spin Launch could inspire a new wave of innovation and competition in the space industry. Ultimately, it's not just about getting satellites up faster. It's about making space a place where more people can participate and create the future. Spin Launch's 5,000 mph satellite launcher could mark the start of a new chapter in space exploration, one that's faster, cheaper, and cleaner than traditional rockets. While challenges remain, its progress proves that innovation can completely reshape how we reach the stars. If you enjoyed this journey into the future of space travel, don't forget to like, share, and subscribe to our channel for more exciting content. Thanks for watching. Until next time, keep looking up and imagining what's possible.